How voice recognition works. Imagine asking your phone for the weather, setting a timer with your smart speaker, or dictating a message without touching a keyboard. You simply speak, and the device understands what you said. This ability comes from a technology called voice recognition. It allows computers to convert spoken words into text and commands that software can understand. What once seemed like science fiction has quietly become a normal part of everyday technology. From virtual assistants to automated customer service systems, voice recognition is now used in millions of devices around the world. So today we are going to walk through how voice recognition actually works and how computers turn sound waves into words. Chapter 1. Capturing the sound. The first step in voice recognition is capturing the sound of a person speaking. This is done using a microphone. The microphone converts sound waves in the air into electrical signals. These signals represent the variations in pressure caused by the speaker's voice. Once captured, the signals are converted into digital data that a computer can process. This digital representation becomes the starting point for the recognition process. Chapter 2. Breaking audio into small pieces. Human speech is continuous, but computers often analyze it in small segments. The audio signal is divided into tiny slices of time, sometimes just a few milliseconds long. Each slice is analyzed to determine characteristics such as pitch, frequency, and amplitude. These measurements help the system identify patterns in the sound. Breaking the audio into small pieces makes it easier for algorithms to analyze speech step by step. Chapter 3. Identifying speech sounds. Human language is made up of basic sound units called phonemes. Phonemes are the individual sounds that combine to form words. For example, the word cat contains 3 phonemes. Voice recognition systems attempt to detect these sound units in the audio signal. Machine learning models analyze the patterns in the sound slices and estimate which phonemes are being spoken. By identifying these sounds, the system can begin building words. Chapter 4. Converting sounds into words. Once the system identifies phonemes, it attempts to assemble them into words. This process involves comparing detected sound patterns with a language model. Language models contain statistical information about how words and phrases typically appear together. For example, if the system detects sounds that resemble set A, it may predict that the next word could be timer or reminder. By combining sound detection with language probabilities, the system improves its ability to produce accurate text. Chapter 5. Machine learning models. Modern voice recognition systems rely heavily on machine learning. These models are trained using large collections of recorded speech. The recordings include many speakers, accents, and speaking styles. By analyzing this data, the system learns patterns that help it recognize speech more accurately. As the model processes more examples during training, it gradually becomes better at interpreting spoken language. Chapter 6. Dealing with accents and noise. Real-world speech is rarely perfect. People speak with different accents, speeds, and tones. Background noise can also interfere with audio signals. Voice recognition systems use signal processing techniques to reduce noise and improve clarity. Machine learning models are also trained on diverse speech samples to handle variations in pronunciation. These improvements help systems understand speech across many different environments. Chapter 7. Understanding commands. Recognizing words is only part of the process. Many voice recognition systems also interpret the meaning of the words. For example, if someone says, "play music," the system must recognize the words and understand that the user is requesting an action. Natural language processing helps interpret these requests and determine the appropriate response. This combination of speech recognition and language understanding allows devices to act on spoken commands. Chapter 8. Real-world applications. Voice recognition technology appears in many modern devices. Smartphones use it for voice typing and assistant commands. Smart speakers respond to spoken questions and requests. Cars may include voice controls for navigation and media systems. Customer service systems also use voice recognition to guide callers through automated menus. As the technology improves, voice interfaces are becoming more common in everyday computing. Chapter 9. Continuous improvement. Voice recognition systems continue to evolve through ongoing training and software updates. Developers collect anonymized speech data to refine recognition models. Advances in machine learning and computing power have improved accuracy dramatically over the past decade. While occasional mistakes still occur, the technology has become reliable enough for widespread use. Future systems will likely continue improving their ability to understand natural speech. To wrap up, voice recognition works by capturing spoken audio and converting it into digital signals. These signals are analyzed in small segments to detect speech patterns and phonemes. Machine learning models use these patterns along with language models to assemble words and sentences. Noise reduction and training with diverse speech data help systems handle different accents and environments. Combined with natural language processing, voice recognition allows computers to interpret spoken commands and respond appropriately. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.